Hello. Today we are going to talk about MQTT protocol and how it works. MQTT is a client-server publish-subscribe messaging transport protocol. It is a lightweight, open, simple, and designed so as to be easy to implement. These characteristics make it ideal for use in many situations, including constrained environment, such as for communication in machine-to-machine and Internet of Things contexts, where a small code footprint is required and network bandwidth is at a premium. I'll also explain in short what machine-to-machine learning means. Since it's tightly connected to our topic, machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy. As for IoT, which is Internet of Things, it is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with a unique identifiers or UIDs, in other words, and the ability to transfer data over a network without requiring human-to-human or human-to-computer interaction. MQTT protocol was invented in 1999 by Andy Stanford Clark and Arlen Nipper. They needed a protocol for minimal battery loss and minimal bandwidth to connect with oil pipelines via satellite. MQTT excels when transferring data over the wire in comparison to protocols like HTTP. Another important aspect of the protocol is that MQTT is extremely easy to implement on the client side. Ease of use was the key concern in the development of MQTT and makes it a perfect fit for constrained devices with limited resources today. The protocol runs over TCP/IP or over other network protocols that provide ordered, lossless, and bidirectional connections. Okay, now let's dive into more detailed view, such as data representations in MQTT protocol. Bits in a byte are labeled 7 through 0. Bit number 7 is the most significant bit. The least significant bit is assigned bit number 0. Integer data values are 16 bits in big-endian order. The higher order byte precedes the lower order byte. This means that a 16-bit word is presented on the network as most significant byte, followed by least significant byte. Text fields in the control panels are encoded as UTF-8 strings, as you can see on the table. UTF-8 is an efficient encoding of Unicode characters that optimizes the encoding of ASCII characters in support of text-based communications. Each of these strings is prefixed with a 2-byte length field that gives the number of bytes in a UTF-8 encoded string itself, as illustrated in the figure. Consequently, there is a limit on the size of a string that can be passed in one of these UTF-8 encoded string components. You cannot use a string that would encode to more than 65535 bits. The character data in UTF-8 encoded string must be well-formed UTF-8 as defined by the Unicode specification and restated in RFC 3629. If a server or client receives a control packet containing ill-formed UTF-8, it must be closed, such as it must close the network connection. A UTF-8 encoded string must not include an encoding of the null character. If a receiver receives a control packet containing this null character, it must also close the network connection. The data should not include encodings of Unicode code points listed below. If a receiver receives a control packet containing any of them, it may close the network connection. A UTF-8 encoded sequence is always to be implemented to mean U plus FEFF, which means 0 with no break space. Wherever it appears in a string, it must not be skipped over or stripped off by a packet receiver. The MQTT protocol works by exchanging a series of MQTT control packets in a defined way. This section describes the format of these packets. An MQTT protocol consists of up to 3 parts, always in the following order as illustrated in the figure. As you can see, first one is fixed header, which is present and required in all MQTT protocol control packets. The second one is variable header, present in some of MQTT control packets. And the third one is payload, which is also present in some of MQTT control panels. As already mentioned, each MQTT control packet contains a fixed header. As you can see the table here. So the position of byte 1 from bits 7 to 4 is represented as a 4-bit unsigned value. And as you can see, we do have here some of the control packet types in the table. So some of them are just reserved to connect, to publish, or subscribe and scribe. So these things are mainly connected to connecting to the server or client itself. The next thing here, we have the remaining bits from 3 to 0. These guys here. Where a flag bit is marked as reserved, it is reserved for future use and must always be set to the value listed in the table. The remaining length is the number of bytes remaining within the current packet, including data in the variable header and payload. Starts at byte 2. The remaining length does not include the bytes used to encode the remaining length. The remaining length is encoded using a variable length encoding scheme, which uses a single byte for values up to 1 to 7. Larger values are handled as follows. The least significant 7-bit of each byte encodes data, and the most significant bit is used to indicate that, that there are following bytes in the representation. Thus, each byte encodes 128 values and a continuation bit. The maximum number of bytes in the remaining length is 4. So, as we mentioned before, so some of the MQTT control packets contain a variable header component. It resides between the fixed header and the payload. The content of the variable header varies depending on the packet type. The packet identifier field of variable header is common in several packet types. Some MQTT control packets contain a payload as the final part of packet, which you can see here. In the case of publish packet, this is the application messages. In the table, which is shown at the moment, this is control packets that contain a payload. This is the list of the control packet that require a payload. This sums up the detailed working of MQTT protocol, and now we are going to move on the pros and cons of MQTT protocol in general.
First, let's discuss the advantages of MQTT protocol. Some IoT devices are movable objects and some are battery-powered devices. This can result in IoT connections becoming unstable in certain environments and for some purposes, which may turn out to be very problematic since reliability is crucial in many industries. So MQTT is really reliable. MQTT adds further message delivering reliability by adding 3 distinct flags. This is referred to as QoS, also known as quality of service. These are 3 possible levels. QoS 0, which requires the lowest amount of network traffic and is perfect for the projects where data loss is neglectable. Also, there is a QoS 1, which ensures that message is delivered, but also allows duplicates. And finally, there is a QoS2, which guarantees message deliveries and no duplications. Also, MQTT protocol payload can carry any type of data such as binary, ASCII texts, and etc. The receiver need to interpret and decode as per format used by the transmitter. Hence, MQTT is packet agnostic. Another advantage is that MQTT is lightweight. MQTT has been able to support the increasing number of small, cheap, and low-powered IoT devices on the market. MQTT's lightweight protocol is well suited for these devices. MQTT protocol is only 2-byte header and a few lines of code. Last but not least is that MQTT is battery friendly. Without access to electricity grids, MQTT consumes the lowest possible energy. Therefore, it is suitable for building devices that must be connected to a battery for years and years. Now let's move to the cons of MQTT protocol. While no one is denying that MQTT is extremely reliable when it comes to message delivery, one criticism is that there are often issues with speed and latency. This is because data has to go through the cloud. And while this isn't too much of a big deal in certain scenarios and IoT functions, it can be troublesome in the wrong kind of setting. Another con of using an MQTT in IoT is that lack of security built into it. It doesn't come ready to go out of the box, and as a result is up to the end user to manage. This requires you to build a security layer on top of the MQTT. Also, centralized broker limits the scalability as each client devices take up some overhead. In order to avail scalability, local broker hub is used. Centralized broker can be point of failure as the client connections with broker are open all the time. Another drawback can be that MQTT protocol is not as easy to implement compared to some other protocols, and also it is a little inconvenient that client must have to support TCP IP. Now let's move to discussing a code example. In order to have a better understanding how MQTT protocol works, let's discuss how to use MQTT in one of the applications management platforms called Cumulosity IoT. We are going to implement a very simple hello world. It's an MQTT client in C language. At the beginning, we define the publish void, which we also call afterwards. This creates a new MQTT message and sets a payload, publishes messages via MQTT protocol, and waits maximum 1 second for a message delivered from the server. On the other hand, our main function configures an MQTT connection. It also registers an on-message callback function, which will print incoming messages. Afterwards, it connects with Cumulosity IoT via MQTT protocol. The next line creates a new device with a C MQTT name and a C8Y MQTT device type. In addition to that, it updates the device hardware information by putting S123456789 serial and MQTT test model and Rev 0.1 revision. Also, in this part, subscription is done to the static operation templates for the device, which is resulted into an on-message method to be called every time a new operation is created. When we start this application, a new device will be created in device management application, and all the new operations added to the device will be printed to the console. Now let's talk about another protocol which is more popular than MQTT, and this is HTTP, also known as the Hypertext Transfer Protocol, and it is an application level protocol for distributed collaborative hypermedia information systems. This is the foundation for data communication for the World Wide Web since 1990. HTTP is a generic and stateless protocol which can be used for other purposes as well, using extension of its request methods, error codes, and headers. Basically, HTTP is a TCP/IP-based communication protocol that is used to deliver data on the World Wide Web. The default part is TCP/18, but other ports can be used as well. It provides a standardized way for computers to communicate with each other. HTTP specification specifies how clients required data will be constructed and sent to the server, and how the servers respond to these requests. There are many differences between these two protocols. According to the measurements in 3G networks, throughout of MQTT is way faster than HTTPs. Besides, in comparison to HTTP, MQTT protocol ensures high delivery guarantees. As I already mentioned, there are three levels of quality of services. MQTT also provides users with options of last will and testament and retained messages. The first means that in case of unexpected disconnection of a client, all subscribed clients will get a message from a broker. Retained message means that a newly subscribed client will get an immediate status update. HTTP protocol has none of these abilities. MQTT has pretty short specification. There are only connect, publish, subscribe, unsubscribe, and disconnect types that are significant for developers, whereas HTTP specifications are much longer than that. MQTT has a very short message header and the smallest packet message size of 2 bytes. Using text message format by HTTP protocol allows it to compose lengthy headers and messages. It helps to eliminate troubles because it can be read by humans, but at the same time, it's needless for resource-constrained devices. I guess with this brief overview, we gave you an understanding of how MQTT protocol works. Thank you for your attention.